So let's get started. So welcome. So this is, I guess, the fourth lecture of today. Uh, Give me 1 second. Yeah, sorry about that. This is the fourth session, and we'll continue where we left off. Basically, we'll look at cloud functions from GCP that we were looking at last time, and then we'll also look at Lambda functions, and then hopefully we'll get onto the next interesting thing, which is container technology. Okay, so that's basically very high level set of topics that we'll cover. But first, I will make a few quick announcements. And then we'll get into the serverless technology that we were exploring last time. So first set of announcements is related to a couple of webinars. So actually one webinar. So let me just share it with you folks. Chat. So let me share my screen as well. Yeah, so this is a link to an example, I guess, MLOps vendor, in this case, Databricks. It recently had a G round of funding infusion. But anyway, so the important thing is they are having an MLOps virtual event where they'll talk about certainly their product, but also you may get a sense of some topics that we may not get a chance to cover here, but I'm sure they're gonna keep it pretty general for general audience. So it's a good thing to check it out. I think it's on 9th. I don't remember. Oops. Yeah, Feb 9th at 10 a.m. Pacific time. So, it's a great thing to, I mean, if you can, try to check it out and attend the webinar. Okay. Second quick announcement is with respect to with respect to code that we are used to see in our classes. So basically, let's go back to MLOps. So this is the folder that we've been, and we'll try to cover module 3 today towards the once we finish cloud functions and Lambda functions. So what I did is add an additional entry in FAQ. So I hope it opens. If not, let's open it here. Nope. What happened? Okay. Wow. Okay. Actually, you know what? Since I have a, so I wanted to show you that in the FAQ, I have a new link to code bases. So code snippets. Okay. So the same snippets that we see in the IPython notebooks, but I just, I just made a separate folder for it. I mean, a separate repository that again, you can git clone and you can pick up the Flask examples from chapter 1. And we'll try to kind of reuse some of them to cloud functions and the serverless functions today. And we'll also reuse them when we talk about Docker and container technology, in the next, second part of today's lecture and potentially next lecture. Okay, so this is just exactly, they should ideally have the same scripts or same function calls or the same scripts that you would see in the code cells in our notebook. Okay, but it's just an extra resource if you want to directly clone this and directly run the, let's say, the Py files on the remote machine, for example. So this is the link. And so what I'm going to do now is, I think some folks were still facing issues on trying to get Jupyter on the local machine. My suggestion is not to worry about getting Jupyter running on your machine. You just need to get for example, the minimal setup is something that I already showed in the, I don't know if it's not working. I already shown in the FAQ, and I'm going to show it now. What I was trying to say is that as long as you can get the PEM file, let's say with an Amazon AWS, let's say free tier machine, then you can, as long as you can SSH into that, then you can run Jupyter from there. And we've seen the command, and I'm going to now start doing that. And there's only one command that I need to run. I have started Jupyter on the remote machine like 3 weeks ago, right, inside a screen session. So from every time I want to get started on work, I just need to run that. There's a long command which says SSH minus IPEM file, of course, but with the tunneling aspect, which is localhost 8889 colon, localhost colon 8888 on the server side and so on. So I'm just going to run that offline. But once I do that, we're gonna see some things that once I do that, we'll get back to these nodes actually. So in the meantime, let me try to also answer this question. But let me just connect to the remote machine. So actually, I just ran the command. So instead of 888, let me do 8889. So this is the remote machine. I think its ID is 594, the password. Okay, yeah. So this is the remote machine. And then I think you can see that it was 7 days ago that I accessed this machine. So once I have access to this machine through this SSH tunneling in the browser, and then I have terminals, I have Jupyter notebooks, so I have the full Python environment, right? So I can do a new Python notebook or a text file, which basically will work with Py files or terminals, okay? So folks who are facing trouble, don't worry about getting Jupyter installed on the local machine if you haven't gotten through it. So with that, let me actually try to answer this question first, and then maybe come back to what I was going to do. So I feel you went a bit fast on showing us how to use new cloud environments. So there was a question about somebody's asking about cloud environments. So as I said again, the important maybe folks who have issues, folks who are having issues, again, stay back right after the class, and we can just screen share and debug things. But how did I get to this page, right? This getting to this page is kind of pretty much done. So anything that you wanted to do on your local machine, let's say Windows or Mac or whatever, as long as you can get to this page, this page requires you having that PM file, right, on getting it from, let's say, AWS. When you sorry. I don't think I'm logged in. But when you log in and start an instance, and we have seen that process a couple of weeks ago, when you log in and try to get rent an EC2 instance, it'll say, hey, download a PM file. And as long as you have the PM file, and as long as you have access to something with which you can SSH, right? SSH is the protocol. Wow, what happened here? That's not good. Yeah, now I don't know why AWS is not working. Hopefully it'll work in some time. But as long as you can get the PM file and have an SSH access, SSH client, so it's just a command line utility to log into a remote machine. Okay, you can also use PUTTY, and I have the video. So I have the video recording, and you can see that in FAQ. There's a link. This link shows you how to use the PM file in a Windows environment. And if you're on Mac, there is a terminal app by default. As long as you can use SSH, space, and we can see those. You can go back and see chapter 1 to see what command it is in the this SSH and firewall. So as long as you can see this command, the last one, sorry, not the last one, but okay, not here. Yeah. So as long as you can run these commands, right? The last one, which is SSH, for example, if you already have the PM file, you just need to add a -i PM file here. And if you can run this, then it's good. And you can directly SSH into the machine itself, which is what the previous thing that I opened showed. Okay. So I'm trying to not spend too much time on this part because I want to get to Cloud Functions. But folks, if you are facing a hurdle with respect to something on local machine, just try to not do anything on the local machine, just run it on the remote machine. Okay, and the remote machine, the commands are exactly going to be the same. And if you're hitting errors, just contact Ting or myself. Okay. So whatever I'm doing here is all on the remote machine. Okay, it's because I've done this port forwarding that I is written here. Okay, so sorry. Um, um, okay, so I just wanted to say that. But what I wanted to get to, let me just leave this, and you can see you can navigate this Jupyter interface, right? It's a very bare minimal interface. Let me shut down these things. And what I wanted to get to before I get to Cloud Functions is that somebody asked, how do you move files from my local machine to here? For example, let's say you have a model file or a Python script. If it's a Python script, you can just create a new text file. Let's call it whatever, like new script .py, and let's say that's the file name. You could just copy paste it, right? Paste here. If you wrote something locally, if it's text files, it's easy to just have using GUI copy things from the server to your local machine or your local machine to server. Okay, so that you can do. Let's not do that. But if you have extra files like a movie.dat file, okay, this is something that I was trying to use when I was showing the recommendation model, right? So just to go from movie IDs to the movie names or the genre, you would need this extra data file. This is actually also is a text file, so you can copy paste as well. But for example, this file with an extension .pkl is something that you might have seen when you tried the recommendation model notebook from chapter 1. It's a file which is not really a text file. Okay, so it's kind of hard to copy or paste from the server and your local machine. Since we already did SSH transfer, so SSH tunneling basically, but since we already did that earlier, so sorry, this is I'll just show you as a SSH-based way to copy files from local machine to remote machine, so that as long as you have expertise in using SSH, and that's basically, as I said, there are only a couple of commands. Let me go back to home. I don't know what temp1, temp2 are. Okay, let's create a new Python notebook. So we saw this. Um, so as long as you have, basically you need to know 3 commands. Let me sh. I think let me go back here. Chapter 1, sh and firewall. Let me go back here. And this is just a summary. And some of you, it's already obvious. So if you have -i and pem file, okay, whatever this is, for me, it was Amazon-flask-python.pem or something. So pem file. This would be one. This is a command that you generally run to connect back to your server machine. So your machine that you have rented on AWS, okay, and you just need to put username is going to be Ubuntu if you picked the Ubuntu machine, or it's going to be EC2 user or something else if you picked a different machine. Generally, I would suggest pick Ubuntu or a Debian-based machine. IP address is whatever you get from the rented machines. Okay, this is one command, and if you just want to connect to the machine, that's even easier. That's just SSH -i, same thing without all this stuff. You don't even need -p22 if you want. This just means port 22, okay, and that's by default is the default port for SSH. So command 1 is just this. Command 2 is this. If you want to get into the machine, okay, if you want to use the terminal and get into the machine and do something on that machine directly, okay. Since Jupyter, you tend to run on that remote machine all the time. If you just want to connect to Jupyter, which is running on the remote machine all the time, just use this. And the last one is the ones I want to show is about copying. Okay, and to copy, I want to show it from my local machine. Okay, so for that, let me run a local Jupyter server just so that you can see. And the only reason I'm running a local Jupyter server is to show you a terminal within the browser instead of switching between windows. Okay, and you can do it with a terminal. On Mac or with Cygwin based terminal or any other place where you have SSH access. Okay, so So the reason this one is a local Jupyter machine, it's Jupyter server running because it's 8888. Okay, there's a slight difference between the URL. So anyway, I just opened it in some folder where I had, and this was exactly the code stuff that I said is available to you guys. So let me just open a terminal here. So now, so this folder has a few things, right? For example, it's basically things which I have already shared on GitHub, right? Basically these files. There may be some extra files I've ignored. So let's say there is a actually let me go to so I have a separate folder called data where I have kept the model. So instead of putting models in the same directory as the py files, I put it in the models folder. Okay, so if I go to models, okay, so you can see there's a recommendation model PyTorch. Previously, it used to be in the same folder. I just slightly changed the code to put it in a slightly different folder. So if I want to push this, copy this file to the server, okay, that's one way. One way I'm going to show. And then if I want to copy some file from the server to my local machine, again, I'm going to use the same SSH command. Those two SSH commands you already know. And we'll just add one, a couple of more commands to copy a file from here to there and copy a file from there to here. Okay, so that with that flow, at least you can, even though there's a remote machine, you are able to at least push and pull non-text files, okay, to back and forth. And this is one example. So let's say we want to copy this file, pickle file, so any file, but let's say this pickle file. Then how am I going to copy it? So I'm going to do sep, okay, and again the same thing, -i. I think I have somewhere that PEM file. Okay, it was somewhere else. So I just put it, if it's in the same folder, it's easy. You don't have to have this extra dot stuff. You have the PEM file and then name of the file. So recommendation model pickle, PKL file. Okay. The extension doesn't matter, by the way. It's just something which is not text. And then just the location of the remote machine. So username and this, and then a trailing colon. Okay, so nothing has changed. So it's just the initial first I guess word has changed from SSH to SCP. It just means secure copy. -i, the PEM file, the file you want to copy, and the remote location where you want to copy to. So let's say I want to push it to Ubuntu, wherever my IP address is, and colon means the home directory. Okay, so currently, let me go back here and say, okay, what is my current directory? It's my home directory, right? This is my username, and this is my home directory. So if I do ls, I have some stuff. Okay, so this was the installer file that I had like 2 weeks ago, and some extra stuff. Let's not worry about that. So if I want to get one more file here, then I just have to run from my local machine this command. Okay, so this this command only because this extra stuff is only because my PEM file is somewhere else. So if I press enter, then it shows, hey, this file 100% transfer complete, its file size is something, and whatever transfer rate and all that. Okay, now if I come back here and if I do $ls, I'll see that file is here. Okay, so that's a command line way to push things back and forth. Okay, so now I only push things from local machine to that side. Let's say I want to copy something from there to here. Then what would you do? So you will still be on your local machine. Okay, so don't worry about the server. You're still on your local machine. And you just need to reverse a few things. So for example, I can do, the command is almost going to be the same. I'll just remove the file that I wanted to transfer from there. And just the first argument is going to be, what is the file I want to copy from there? So hopefully I know the root. For example, if I want to get the same, okay, what file do I want to get from there? Let's see. I'm going to create a simple file, echo Asia to Asia.text. Okay, I'm just going to create a text file. So how do we know this is a text file? You can do less or cat or something to look at the text file. Okay, it's a text file which has some, I don't know why there's extra stuff here, but yeah, I mean, it's a text file. Okay, you can do less or you can do cat to see what the file is. Oh, maybe not cat is not a good idea. Maybe it is. Okay, so it's just a text file. Okay, it just has my name. Now it's on the server side, as I said, so that we can see by just again doing ls over there. And you can see there's an extra file that I created just now. Okay, so this is a very dumb way to do it, but this is just for testing purposes. So there's some file on that side. It's a text file. Now, how do I copy it from there to here? Come back to our local machine. Okay, we just need to have SSH and SCP, and SCP just comes with SSH. Okay, whenever if you have SSH access in your SSH command on your local terminal, you'll generally have SCP. Okay, it just comes bundled. Um, so we have the colon command here, and you just type. You can type tilde slash if you want, but if not, you can just type txt and then dot. Okay, space dot, and that should hopefully, yeah, that copied that file from the remote machine to here. Okay, so that's the second part. So copying a file from my local machine to remote machine is basically a command like this. Okay, let me actually copy this and save it somewhere so that if needed, I'm gonna save this and send it to you guys. This is from local machine to remote machine, and if you want to get it back from remote machine to local machine, some file, as long as you know its root, its path, then this is the way you get it back. Okay. Hopefully this, I know folks are a little bit more comfortable with GUI tools. There's actually, just as a last disclaimer on this thing, sending files from A to B, I mean, a local machine to, server and server to back. You can also use some GUI apps. Okay, there's an app called Fetch for Mac OS, which does that, this type of copying, in a very nice GUI format. You just need to somehow log into the remote machine, and it's basically using the PEM file. On Windows, I am not sure. I don't know the name on the top of my head, but I can share something during the break or afterwards. Okay. So if you want a GUI-based thing. So hopefully this clarifies at least the file transfer. Now, a second thing I want to also touch upon is the fact that let's actually not worry about the local machine anymore. So let's close that local machine completely. So now we are completely on the remote machine, this and this and all that. So let me close this. What I also want to show is how do you deal with the fact that this, let's say, let me go back to the home folder, and sorry. Okay. I just wanted to clean up a couple of folders which are existing here. So temp1, temp, and so on. But anyway, so this was the initial file that once we got access to AWS machine, we downloaded this mini conda file and we ran it to get our Python conda environment. And next we did a git clone to get this MLOps folder. Miniconda installed in the local directory, so that way it's actually pretty good, because if you mess up with something with in Python, you can just delete this folder and everything is always inside the folder, so then your system is clean. This Google Cloud SDK we'll see today, but that's something that I was doing towards the end. So untitled is just, I just opened it, and these two files we just created. So what I want to show is that this folder, MLOps notebooks, let's again go back. Actually, let's use the terminal this time. So cd MLOps. So if you do git status, there were so many things that changed from last time. Okay, so if you look at this, last time, I did a git clone last time, and then I kept discussing various things, and a lot of things have changed. So if you want to see what changed, for example, I can do git def of let's say FAQ, and I'll say, hey, something's changed. I don't know exactly what. but it's not also interpretable for notebooks, so it's fine. So um, what I want to say is that, hey, I've now changed. Now I want to fetch the freshest version of notebooks that I have from, let's say, the instructor's page, right? So this is the page, and how do I get the freshest version? I can again do a git clone, right? I can do again git clone on the remote machine. I can say, hey, this is this, let me rename this folder to be from whatever last week, and let me git clone again and do a fresh start. Okay, that's one way to deal with this issue of. So if you run git clone here, so let me go into that. Sorry, not git clone, sorry, git pull, which is the typical way to do it. It says aborting. Okay, that's because there are some local changes that we made that are not the same as that's going to conflict with these updates that's there in the remote folder. Okay, so this origin, the original um, file set, okay, which an instructor is providing, right? So to avoid this issue, I would say the simplest thing you can do is just create another, just move this, let's say move MLOps to MLOps Jan 2901, let's say 29th, and that's gone. So now again, you can do git clone of the um, this actually same link, but let me copy it from here. Um, yeah, and then you'll get the latest set of notebooks. So that's again MLOps, right? So then we can go to MLOps, and you'll see that there's updated information like this chapter 3 this time, whereas previous time chapter 3 was incomplete, for example. Okay, I would say this is the simplest version. There are many other ways to deal with this, but just to, I mean, I'm just for suggesting this because folks may hit this hurdle if you change files from last time and then you do a git pull to get the next chapter, or freshest notebooks, then there'll be a conflict. Okay, there are other ways to resolve it. Maybe we'll talk about git itself in a separate session, and then we'll talk about how different ways to manage this. Okay, so hopefully you are able to get the latest notebooks all the time using git pull, sorry, not git pull, but git clone. And if you had a previous set that you're working with, just rename the folder into something else. Okay, for now. Okay. Any questions so far? I think I spent a lot of time on some of the logistics, but it's worth bookkeeping on these things. Um, okay, if not, then we'll get back to, let me exit this. We'll get back to cloud functions. So this is moving files across. Let's just leave it. Okay, so now let me go back to home folder. This is home, what was running. I'm gonna shut down. Let me go back here, and this was the previous snapshot. So now if in this folder there's not going to be any, this is the freshest stuff, and this is where I was saying that in the FAQ there is this extra link for the code examples. But let's go back to cloud functions. So okay, what happened here? Okay, console. And the last time what we did was experiment with a simple prediction model. Okay, and just a recap, and it's pretty simple here. So the way you get to navigate a cloud function is you can use the search bar. It's I guess one of the easier ways to get there. Get there, create a function, and you can choose a few things, and function name and so on. Which region just impacts where your machine is. Sorry, where your server is. Okay, not the server, the AWS server, but this is called, the serverless technology is backed by some servers, right? So where the servers reside. And last time we said, hey, let's do just a very simple thing, which is unauthenticated invocations. So there's a few extra things, like you can choose, like if you have a very heavyweight function, then you can choose how much memory it needs. For example, you want to store some database, read from a dictionary or something, some data file and keep it in memory, and so that every time you get a request, you can immediately respond. So that you can change things here. Um, um, yeah, so that's good. Yeah, and last time we saw how to change the and pick one of the environments, I think, and uh, pick one of these Python environments, right? So let's say we picked 3.8. Okay, so what I'm going to do is now adapt the code. So since I have this nice repository, easy to access repository, rather than looking at the code pieces within the notebooks, I'm going to just pick one of these. So I actually have, so last time we saw a food service Flask um, example, right? That's not related to model predictions. There's actually, so in Flask recommendation service is something that we saw a couple of lectures ago, where we were just predicting movies, and I think even last time we saw this. So for just serverless technologies, I'm going to pick a very simple um, um, model, which is what I was introducing um, towards the end of last session, and that's what I'm going to show for both Cloud Functions and um, uh, Lambda functions. Okay, so what is simple regression? And for that, you'll see that for different prediction models. So say in this Flask, if you look at, there are so many Flask files here. So out of these, all these ones, there's actually only two for which we had to explicitly do some training. Okay, and so that's why there is a like, for example, the recommendation model is a PyTorch based model. So there's an inference file and there's a training file. What the training file does is use the data to produce a model, dump it to disk. An inference file reads that model from disk and makes some predictions, okay, offline. And similarly, I actually have a couple of new files which do the same for just simple regression. And this is just for illustration. You don't have to pick with simple regression, but it keeps everything pretty clean for us. So there are two files, and then there's a Flask file as well for regression. We'll look at it in a second. Okay, so let's look at train. If you look at train, it has a bunch of imports, very simple imports, numpy, math, and pickle. And there's a fit function. Okay, so it's quite verbose, but at the end of the day, it's just doing a simple one-dimensional regression fit. Okay, so if you look at so it only needs a function call like this. So if you have data, let's say you have data with just one feature vector, 1, 2, 3, 4, and something like that, and then let's say y is a linear function of x, then you can just pass that data to the fit function, and it'll produce a model function on the model parameters. Okay, and here I've just shown you how you would dump. So if model parameters is just numbers, so in this case, you will see that model parameters that are being passed back from the fit function are two numbers. Okay, it's just the intercept and the slope. So there are two numbers. Okay, in a list format. Okay, and I can just dump that list. That's model parameters here. I can dump that list to a file. Okay, and I'm using pickle as a way to write it to file. I can also write it as a CSV file with a comma b or things like that. Okay, there are many ways to do it, but here I'm just showing you that this is the way you dump a model to disk. Okay, this is a very simple training example. I've really removed all sorts of other packages to just show you, hey, this is how one-dimensional regression looks like in terms of training and getting a model to disk. Okay, and once you have a model in the disk, then there's very simple ways to read the model from disk. Okay, you just read the model parameters. Okay, reading the model parameters, you do it using, for example, pickle load is one way to do it. Okay, and once you have the model parameters, you can pass the model parameters to instantiate your model. And since it's just a linear model, given the model parameters b and a, it's just saying uh, 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 it's just defining this function with b and a. Okay, and then returning that function. Okay, that function is our model. And once I have the model in this offline, this is just inference file. So it's just saying, hey, if I produce a bunch of numbers inputs, then what is my model going to predict? Okay, it's just model bracket whatever is the input. And so there are several inputs that I have created in this line number 18, and I'm just plotting those. Okay, so if you do this, then you will get a um, you'll get the predictions. Okay, and we can just run this locally actually. So let's chapter 2. Let's create a new notebook. So, I mean, this should not run because, first of all, I don't have the model, the pickle file here. So it should error out saying, hey, matplotlib is also not installed. Okay, so let's install that. $conda install. Okay, so let's install matplotlib, but let's also do, oh, actually from here, it's going to be complicated. It's, okay, -y. I forgot to do. So if you want to, if it asks for a question and you want to answer by default sorry, yes, then you just give an extra thing called -y, and then it just installs. Okay, so it's done executing. So now matplotlib is not going to be the issue, but the issue is going to be, hey, this file is not there, first of all. So it says, as you can see this. So I'm going to create that file as well. So let's go back to, why do I have so many? Okay, let's go back here and train. I'm just going to copy this because actually, even, maybe I can just clone this. Let's go back here, code, copy, untitled. We install something below. We'll oh, this is in the chapter 2 folder. Okay, let me not clone it here, but create a new terminal. Okay, so we had just cloned this folder earlier, right? So I'm just going to do the same thing, git clone. Sorry, not MLOps notebooks, but the whole script. Oh, actually, I want to clone the other thing. It's called MLOps -code -examples. Okay. Okay, so we have the folder, which is code examples. Let me go into that folder. Okay, so here actually, if you open a terminal in Jupyter Notebook, sorry, Jupyter Server, sometimes it's your environment is not instantiated. So you can manually activate it. There are ways to activate in different, activate it automatically, but let's not digress. So now if I run Python simple regression train, I think it'll again error out because the folder location is not present. So let's go back to the home and let's open code folders, code examples, and simple regression train. And I'm just going to change this location. Okay, so I'll just keep the location, the same location. And let me run this. Okay, so what we got is an extra file. What I'm going to do is copy that file into notebooks chapter 2, just so that we have it here. Okay, so we do $ls, sorry, exclamation ls, then that file is here. And I'm just gonna, okay. So what we've done here is just read that file. It's a pickle file dump, and it's basically supposed to be just 2 numbers, as you can see here. Model underscore params is just 2 numbers. And once you read it, you can just, here's a plot, and it's just a line. Okay, so okay, so now we have this. Now what I want to do is do the same on GCP. So so for that, what we need to do is be able to send this file. So somehow read this file from GCP, so from Cloud Function. Okay, let's go back there. So you can see that here we can only have regular files, right? So what I want is to be able to read this pickle file from somewhere, and therefore be able to make this prediction, right? So that's going to be the new thing this time. So last time we've already seen without dumping model to disk, how do you make a prediction? Okay, so that was a very simple example where I directly um, copied this whole thing, fit file and everything, and I said, hey, we can directly make a prediction. I fit in real time, and I showed that, but that's not the way to generally do it, right? So what we need is change the main file, change the requirement file to still work with the simple regression model, but we need to read the model file from somewhere. Okay, and that somewhere is going to be from Google Cloud Storage. So that's what we're going to spend time on in the next few minutes. Any questions about where we're going or any confusion? Okay. If not, so what I'll do is I'll not show again how we can do a hello world type of an example here. What we'll directly get to is
Question: we should be able to follow whatever you're doing on the AWS server that we installed, right? That's what I
yes. So
meant
everything
for.
that I'm showing here is on the AWS machine that I
Right,
started like 2-3 weeks ago. Yeah,
right,
yeah.
right.
And that's why I've been showing you how to copy files A to B
Correct.
or clone repositories again and again. And yeah, you should be able to do this whole thing, whatever I'm doing here. Yeah.
Yeah. Okay.
The only thing, yeah, you just need to have a PEM file on your local machine so they can access it to these machines. Yeah, I think I showed you here, right? I think there was an a different untitled folder where I was showing, I wrote those SSH commands. Those are the commands that you need to know to get
Okay.
access to the machine, and then you'll be fine. Yeah.
Sounds good. Yeah. Thank you.
So somebody's concerned that they're not good with the command line. So I think it's a very important concern for many of you who are beginners. So I think the way to get around it is to not so there's going to be several commands, right, on the command line, but we just need to know a few. And by when I say we just need to know, it's just think of it as cheat sheet. Okay, it's not that you need to remember, hey, first term is this, second term is this, third term is going to be something else. You can always go back to the documentation, so you can always go back to the notes that we have. And if you hit hurdles, ask. Okay, immediately ask, because you are currently in the beginner phase. So it's totally fine to ask, hey, this command is not running, and here's the exact error that I'm facing, and we can work around it. Okay, so it's going to be a little bit of a learning curve, but we are only seeing the commands that are minimally needed for us to deploy ML models. Okay, on these professional locations, right? I mean, these AWS or Google Cloud or whatever. So yeah, so there's another question. So somebody's saying there's no surprise quiz on those. So there's not going to be surprise quizzes in this course. I'm telling you beforehand. But I think everybody's interested in knowing about MLOps and deploying machine learning models and technologies around it. So I hope you'll get exposure to those technologies. Okay. So do we need to know about these codes? No, I don't. I mean, so these codes are just, so for us, I think the codes, for example, that I'm showing here, right? All these codes, I mean, the Flask codes have some extra stuff to have a web app, right? So to serve an ML model, you need to have a server, like some server code. So Flask is one example web framework in Python that you should at least be a little bit familiar with. The actual models don't matter to us. That's why I'm showing a simple regression model now for serverless. And previously I was showing some recommendation model, the previous two lectures, right? Yeah. So the models don't matter. So the code for the models themselves don't matter. If you follow the regression example, and if you've seen R before, they have a very similar syntax. But other than that, all we're trying to do is get a sense of, hey, how do we deploy a model in a web server? And that's what Flask was allowing us to do, to today, and yes, last time we were just trying to see, hey, how can I do it on serverless technologies like Cloud Functions or Lambda? And later part of today and maybe next session, we're going to look at, hey, how do I Dockerize or do some container stuff? And we'll, of course, motivate why do we need to do that, but how to use Docker and again, server model. Okay. So for all of them, just knowing how Flask works roughly is good enough. Okay. And we have seen this, right? So for example, Flask, the food server thing, or even simple regression thing actually is much more simpler. So you just need to instantiate Flask, have a model, uh, ready, and then the Flask part is just saying, hey, start a Flask app and match an URL to a function. That's it. That was the key takeaway from Flask. First zero data takeaway. Like if you can map a URL, so this URL is saying whatever is the IP address slash means this function has to be executed. Okay, and this function is what is going to say, hey, did you pass an input? If the input is there, let me just make a prediction here. And if the input is not there, then hey, input is not there. That's all. So as long as you know roughly that this is the part related to the web server, and you can have any model, okay, whether it's simple regression model or anything else. It's just it's not critical for us. So there's some more question here. Syntax error with the PM file when trying to SSH. Syntax error. Oh, from a Jupyter file to my local machine. No, you need to use the PM file on your local machine to connect to the remote machine. So Alex is asking a question. Syntax reference PM file. Um, so are you running it? Okay, let me just open. Sorry, I think we are going a little bit of tangent here, but let's go back to um, home here. I think I had a, moving files across, let's say. I'm opening it. So Alex, if it's short, maybe you can tell me if you're facing any issue with any of these commands.
Hi. Yeah, I tried. So I guess my confusion is at the beginning of class when you were talking about this, I already ran this to my local machine and was in SSH. I didn't know, were you run? I guess where my disconnect is like kind of running Jupyter commands on your local machine.
Oh, no. So no Jupyter commands on local machines, right? So this, you just need a browser on your local machine, and you just need this utility SSH program, right? The command line program. And you, of course, also need a PM file. As long as you can log into the remote machine, okay? And as long as you can run the Jupyter Notebook command on the remote machine, once you log in, you'll get a terminal interface. And I have shown in the, for example, sorry, let me close it. I've shown in this example, right? So let's go back here. So if you want to look at this, so there's a Zoom recording which shows how to use a PM file to log into remote machine. You can look at that if you're on Windows. But that's all. You just need to use these commands to, so this command lets you use your local browser to connect to the Jupyter instance running on your AWS machine. Okay. I just ran this. So at the beginning of the class, what did I do? I didn't do any setups, right? I just said, hey, I started this AWS machine 2 weeks ago, and it's anyway free tier. I can run it for 12 months, right? It was running, and 2 weeks ago, I had started a Jupyter instance, Jupyter server, right? So, and how do you start it? You just type Jupyter space notebook, and there's a example. There's information right here in chapter 1, right? So intro and setup Python. You can see how do you start. You do screen something and then just run this command on the remote machine. Okay, and that's it. And then you forget about the remote machine.
Okay, perfect. Thank you.
Yeah. I mean, in the sense you can disconnect and all that, Jupyter will continue running. So every time, Jupyter will continue running. So today, all I did was just run this command, right? Today, I just ran this command, opened my browser, went to localhost 8889. I said, hey, connect to my machine. That's it. And everything that I'm showing in this browser is, I'm just running it on the machine that I have, the remote machine.
Okay, thank you so much.
Yeah. So nothing is running on my local machine. So yeah. And of course I'm just using URLs like just to
Professor,
browse
when you
URLs.
have that so this is Anupriya, so when so I guess with the key thing you told that you must have a public key and a private key, I guess.
Yes. So the public
And
key,
then
private key stuff was for a different vendor. So I think in the first lecture I showed you how to do it with DigitalOcean. So they don't
yeah,
give you a PM file. So PM file is equivalent to the public key, private key ideas that I showed you. So that's the way you
okay,
would generally do it. If somebody just gives you a remote machine and says, hey, here's SSH access, get into that machine. Instead of using username password, you would use a public and private key, paste your public key onto the remote machines, authorized keys file or whatever, and do that way.
mm,
Amazon makes it easier. It says, hey, don't worry about all that. I'll give you a PM file. And in fact, you just download it using the GUI,
yeah.
and you can just SSH using only that. You can't use username password, for example.
Okay,
Yeah.
so then we don't need any other keys apart from the PEM file.
No SSH keygen and all, some commands that I think were maybe in the first
Yeah,
lectures
yeah,
recording.
yeah,
No, you don't need all that. Yeah.
yeah. Okay, thank you.
Um, yeah, and if people are facing syntax errors, let's talk about it right after this lecture, right? So stay back and we can screen share, and I'm sure I can add, help you give some hints if I know the answer. So sorry, I think I digressed a little bit here. Um, yeah. So what I wanted to get to was that last time. Um, Yeah, I wanted to show you a few things, but I think what I'll just tell you what I'm skipping over. So actually any of these Flask py files here. So let's say the food service. I think last time we saw the food service thing, right? So we ran this Flask app, and if people hit the website and with some query, it would just pick some image and display that image, right? So we were doing that. This, so that's in this, sorry, that's in the food service py file. It's just a copy from our, this particular notebook file. Is the same copy. Um, you can deploy this on Cloud Function as well, or AWS Lambda. I was going to show that, but I think in the interest of time, I'll just now what we're going to do in the next few minutes is go back to this create function, somehow change the main file requirements file, just like what we did in the last lecture. Okay, so it's going to be very minimal change since we are going to only look at a simple one-dimensional regression, the simple regression example. So we'll change this, but the new thing is going to be that we'll try to read the model file from a location which is on the Google Cloud as well. So we'll now introduce a new managed service, which is the storage service. Okay, so we'll pick up. So right now, what we're using on Google platform is just one service, right? The serverless service, which is Cloud Functions. So we're using Cloud Functions. We'll also try to use the Google Cloud Storage (GCS) as a second thing, or on which we'll dump a model file. And therefore, the Google Cloud, so when we create a Cloud Function, it'll be able to read from the Google Storage, Cloud Storage, the model file, and therefore now ready to make predictions. Okay, and we'll see how to do that. Okay, so just in English, that's what we're going to do. So let's get um, started with that. So um, sorry, I don't want to keep so many things open here, but yeah, sorry, I think I wanted to go to one. Yeah, I don't know what this is. So let me just close this. Okay, this is our regression model. Let me keep it. This also, let's keep it. Let's close this. FAQ, let's close this. Yeah, let's, again, this also, we don't need it. So we are in chapter 2. So just to, again, gain our bearing back, where are we? So we're talking about Cloud Functions. So last time this is what we were looking at, section 3, 03 is where we were kind of discussing, and we saw some hello world example, and towards the end we were trying to get a model, the simple regression model itself running there. And I showed you a very, I guess, suboptimal way to do that. And today what I'm going to do is use the second thing, which is Google Cloud Storage, to do it in a little bit more proper way. So let me open that just to show you how to get set up on that. Okay. So sorry, so I'm scrolling quite a bit because the example here is, again, instead of food service, there's a weather example. Now, I just checked that now the National Weather Service's web API does work. So if you want to try out working with this weather example, that's fine too. You just need to, so you query for, let's say, weather of Chicago or Los Angeles, and you'll get the weather for that, okay, from the National Weather Service. So and we saw how to make queries using Postman and stuff last time. So where we are, what we want to do for today is, for this part, is to now try to put a model on the cloud. Okay, put the model file on the cloud. Okay, so how do we do that? So this section is describing how to do that in a using command line. And and actually, what I'll try to do is in real time, try not to do it with command line, but do it using the GUI, at least putting the model file directly over there. So let me, instead of this one, let me again go to Google Cloud. Okay, so go to storage. Okay, you'll see some files here. Sorry, some stuff here. So don't worry about this. You'll probably have empty here. Now, so we're gonna try to create basically something equivalent to a folder. Okay, it's going to be called a bucket here, and for certain technical reasons. But basically, we're going to create a folder where we can dump the model file. Okay, and we can do that using command line or using GUIs. Okay, and by the way, many of the things that we see in this lecture, especially from last lecture onwards, especially using AWS or Google Cloud, many of the things, they can be either done via command line. And when I say command line, using in a programmatic way, whether it's command line or through Python, statements. You can do things like even creating a bucket, for example. I can click here and create a bucket or whatever folder. I can do that using Python as well, directly writing a Python line, and similarly on AWS as well. But so for now, so for this section, we'll try to do it. We'll at least upload the file using GUI, but read the file in the Cloud Function using a programmatic way. Okay, so let's do that. So let's create a bucket. Simple regression bucket. Let's call that. This, I think we can not worry about it. Continue. Which is a default storage class, standard. I mean, so there are different, pricing also for, as you can see on the estimate, price estimate on the towards the right-hand side. So just continue. And how to control access to objects. It says the two options. Using object level permissions, or some using bucket level permission. So let's just pick something, option uniform, for example. Let's continue. Advanced settings is optional. We're not gonna do anything. Let's just create. Okay. So it's what we see here is a interface. Let's actually close this learn part. So this interface is just here it's showing the name of the bucket or the folder that we created. And since we have this folder, we can there are clearly three blue buttons where we can actually now upload folders or create more folders. Create folders or upload files. Okay, we're going to just do upload files. You can see that there's this name called create folder, and previously it was create bucket. There's a slight distinction between them, but for now I will gloss over it. So we'll just upload file. If I click on this, it'll actually open stuff on my local machine. So let's see. Okay, let's do. It's gonna open my local file, and this is my local folder. And for instead of the remote machine, but I do have that. I mean, and I do have that simple underscore regression.pickle file, right? That I copied. So that I created on the remote machine, and I just showed you at the beginning of the class how to copy that file to your local machine, right? SCP from remote machine, a file name to dot means you'll get it. You'll get it. So I'll just copy that file that I have. Okay, Okay, so I just copied that file. So it's a very small file anyway. So I have this file here. I'm just gonna upload it. Okay, and so yeah, I have this file, and great. So I have this file now. What we need to do as the last step is somehow, we'll go back here and edit our main file and requirements file to now, serve model predictions, but by using a model which is dumped over there. So first we need to read that model from the from that location. Okay, so for that, let me um, so yeah. So if you look at this part, so this section, right, saving model to cloud, what I just showed you is a GUI based way, and it was pretty easy, but this manual uploading of model, sometimes you may not want to do it. You may want to programmatically, every time, every night, every weekly, you may train a model, and you may want to have a bunch of lines in your, for example, Python script, which would say, instead of save the model to disk, save the model to GCP. Okay, and that's covered, in the programmatic way here, but I will skip over that in this description for the interest of time. It just shows you how to dump model there, and also see how to read the model back, for example, a model as well as any file actually. And here I'm just showing you how to do that. Okay, here. So we will skip over that, and maybe we can come back to this if there's a chance again to talk about Google storage and access to Google storage in a programmatic way. We will look at part of accessing Google storage in a programmatic way anyway, which is next. So this is the next section, section 4. And here, the description, this section is talking about a slightly different model, the recommendation model, but we'll kind of follow the same idea. So we'll do that in real time. Okay. So if you look at our yeah, so if you look at our code examples, and let's go back to simple regression service. So what this Flask simple regression service is, if I run this, it should just be able to, so even without serverless, it should be able to run this, I guess, web server, which will be able to make predictions. And you can actually check this, like, for example, here we are. So if I do Python Flask, okay, I don't think the serverless, what is it called? The pickle file is here. So I just need to edit that once. Let me go back here. Sorry, this is just a question of having the appropriate paths. So simple regression service, it's trying to read the model file from somewhere else. So let me just change that to the current directory. Okay, and once I have made this change, in the current directory, I do have the simple regression pickle, which I had just copied. So with that, I can then run Flask simple regression service, and it should run. And I'm trying to remember, okay, on AWS, did I allow port 5000? Not sure. So let me actually go to AWS. For some reason, AWS is failing for me right now. Interesting. Oh yeah, great. I just wanted to again go back and check whether the 5000 port is open for the world to read. If so, since if it is open to read, then since I've just run the Flask app, I should be able to access it. Okay, but I just don't know why AWS is so slow here. Okay, in the meantime, so I'm going to do two things in parallel. So I'm just, since we just ran the Flask app, I just wanted to see if it works anyway with just the Flask thing. Um, let's come back to, yeah, sorry. Yeah, so what we're going to do now is pretty much use, so you can see that I need pickle file, sorry, I need the pickle package. And from Flask, I also need JSONify and request. Okay, so I need two packages as imports. Okay, so if I can just go back here and say requirements, I just need Flask. Generally, you also specify a version number, but for simplicity, actually, it will not matter for us. But the right way to do it is to also suggest a version number here. Okay, Flask, and we'll need pickle. So these are the only two things needed, as you can see, to serve our model. And that's good. So one file we do have. Next, the main file. What we're going to do is go back to our, the model description and copy this part. And this is where a lot of changes will be. So let me remove this. And the change will be just on this part. Okay, the change will be, instead of opening a file from a location like a disk location, which is not possible because now this is it's on the serverless technology, and it's not even clear what this root means. We're going to just change this to the Google Cloud Storage location where we have just uploaded our model. Okay, so that's the only one. That's pretty much the change. And once we have that, we don't have to do this because this is actually serverless itself. Has a it already does this routing. Okay, so it says what is the default function that you want to call when somebody hits your serverless address. Okay, serverless domain address. So let's just copy this part and go back here. Okay, and our entry point is going to be predict. Okay, and just to ensure, it's going to be slightly different from the Flask code base. So we'll have to explicitly mention the request object as the input here, and everything else remains the same. Okay, so it just checks if X is an input. X is a feature vector, so it's a feature, I guess, one-dimensional feature vector. If it has been passed as input, then just call the model on that input, and the input generally is going to be like a text. Is going to be in the string format, so that's why we are converting it to the float format here. Calling the model function, it just produces an output, like a single output that's stored in the prediction part of this dictionary here. It's a dictionary with input and prediction. And then we're going to JSONify it. JSONify it is just a way to, I guess, beautify your output. You can certainly return a text output if you want, and that's it. And if you don't find X as an input, then you just return saying, hey, I could not read. I mean, input X was not passed. Okay. So the only thing that we're missing now is somehow, not even this part, somehow read the model parameters. Okay. So how do we do that? Let's okay. Maybe we'll also need to yeah. Okay, I think I missed one more thing. So to what we need to do, there's one additional package that we need to install, which is Google Cloud Storage. Okay, so this is the one extra package we need. And then in the main file, what we'll do is so all this stuff actually we'll have to actually I think earlier I said you need to load it once. It's not the case. So every time the function is called, the cloud function is called, it needs an initialization. Okay, so And so you can have a function in a function like this. I think it's a 2. And what we'll need to change is this, as I said earlier. And okay, this is good. So what I did is just put everything inside the function call. So I can also do import Sonify, import pickle, and we also need to import the last thing, which is storage. Okay. With that, what we need to do finally is just change lines 13 and 14. Okay. Basically the reading of the model. So okay, so okay, so the way we'll change it is the following. So we'll try to use this this new Google package that we imported. So from there, we can get this storage object. So from storage, we can say, hey, create a storage client, and then we need to attach the right bucket. Okay, so we just, which bucket was this? It's called the simple regression bucket. And copy that and paste it here. Okay, so what we've done is attached a bucket here. And since we are on Google, it actually doesn't need extra authentication at this point. And then within that bucket, what do we need is just this guy, right? So simple regression.pickle. Actually, you can also copy it from here, but simple underscore regression.pickle. Okay. And one, I guess, suboptimal thing that we're doing next is to write it to a temporary location. Okay. This temporary location is allowed for Google Cloud Functions. So what we've done here is to read a model from the Google Cloud Storage and save it in a location which is, it's called a simple regression dot pickle, and also change this to /pmp. Okay. So, and that's it. So now we have read the model, and we have to read this model. So what's happening here is a little bit inefficient. We have to read the model every time a new request comes to this website, okay, this cloud function. And once we read the model parameters are now read, and therefore the model object is created. And from using the model, we are going to respond. Okay, so let's see. I hope I covered everything so that it works. Any questions about this part? I think I missed looking at the chat. Yeah. Yeah, again, I want to again note that when I'm creating this function, I gave an unauthenticated access, HTTP access. So if you don't want to do that, then there is some extra work that you need to do. Okay. So that we will not cover, as it's a little bit more complicated. Yeah. So the nice thing about, okay, it did not, so let me just see what the errors are. But the nice thing about this is that every time you just have to, you don't have to touch anything on the Cloud Function side. You can just change things on the, you can just delete this file, right? So in this bucket or folder, you have this file, which is the model file. Every time you have an updated model, you can just update this. And the same thing is going to be read again and again by the Cloud Function. So the model serving script is pretty much agnostic to the updated models, except for it just needs the URL, or basically the location where you save the model. It just has to be, updated. But if you keep it fixed, then you can keep updating this model here. Of course, make versions of it and store it, separately. But this is one way to do that. So let me see if I can figure this out in real time. If not, I'll just figure out something. Okay. It's saying pickle is the error. Um, okay, so what I'll do is try to fix that in during the break, so that there's a pickle 5 version as well. And so let me check that. So we'll evaluate, get it running during the break, and we'll move over to Lambda function. So before we, so let's take a quick sneak, I guess, preview into Lambda functions first, and then um, um, get back to this. Okay. Okay, this may not be. No, why GitHub is also slow. I have no idea what it's asking. Let's go back here. And chapter 2. Okay, so since we saw Cloud Functions, and I'm just going to finish up, we had a small error there. I'm going to check the dependency a little bit. And model of that, we've seen Cloud Function. Cloud Functions was pretty simple. We just had to specify a requirements, just summarize, requirements file, the main file, which has the appropriate function call, the appropriate function, the predict function or hello world function, whatever, and a way to get the models from Google Cloud Storage, read the model, and immediately make predictions. Okay, that's what we did. Lambda function is going to be very similar. Okay, again, these are going to be really small, I guess, resource constrained, but managed services for you to just focus on your code, which is just literally your script, your model serving script, and not worry about network and storage and computing and all that. Okay, so it can be used internally as well as for model deployments. Sorry for the typos there. So to get to what happened here? For some reason, AWS is not efficient today for me. Great. Okay, I'll try to figure out why it's not efficient at the moment. Let's come back here. So this is the interface that you'll see, and EC2 is what we accessed last time, and this time we'll access a Lambda. Okay, it's bucketed under compute, and you'll see that there are many services on AWS. You can see there's the bucket under storage, there's a bucket under databases, there's a bucket under analytics. Okay, which is actually related to what we also want to do later on in this course. And there's also security and compliance. Okay, and this is an important thing, especially in organizations where different folks have different identities and different roles and different access levels, right? So that's captured using security and identity, and there are many other things here. Okay, so what we'll try to do is do hello world Lambda, hello world version of Lambda, but I seem to have an issue with AWS. So let me try to fix this. And let's take a break now and resume at, let's say, 7:33, and we'll get back on track. And I need to figure out why AWS is not working for me. Okay. And if you have questions, collect your thoughts, and maybe right after the break we can take a couple of questions and see. Okay, let's take a break. Resume at 7:33. Oh, okay. Let's resume. So uh, let me share my screen again. Does anybody have any questions in the meantime? So what I've done is I just checked what the error was earlier. It had some issues. So actually, I forgot to include NumPy. So that was the issue. And actually, we don't need NumPy. I think it's just a suboptimal thing that's um, it's just a suboptimal thing that happened to be dependent on. So basically, the requirements file changed. I dropped Pickle because Pickle actually is provided as part of Python itself, Python environment itself. And so what we need is Flask. We need Google Cloud Storage to read the model, but we also need NumPy because it turns out that the model Pickle file, the model that I wrote to disk, it's a uh, NumPy ND array rather than just a number. Okay? If it was just a number, an integer, or a float, then I don't need this extra dependency. But um, it just seems like I need that extra dependency. So that's the only issue. So otherwise, this script here is able to work. As you saw, that there's a green check mark next to it. And if you go to trigger. So how did I get here, right? So again, go back here. So on the cloud functions, you'll see all the different functions that you have. Click on the name of the function, function 3 in my case. And if you go to trigger, it'll show you what's the URL for this function. So for example, I can just share it. Yeah, so you guys can click on this function and see what it does. It's basically, as you can see in the source, it does a few things, right? Every time you hit, it's actually executing all this. It's importing Flask, a specific function Flask called Jasonify. It's importing Pickle. It's importing storage object. It's defining these models. Sorry, this model function. Now it's reading something from Google storage and writing it to a temporary location, and it's reading from that temporary location. And finally, it's setting up the model, which is, model has two parameters here, just the intercept and the slope. And then it's saying, hey, did you pass X as an input? If it did, then let me try to respond back by saying, hey, here's what the input and here's what the model is predicting. And if in any other case, there will be many sources of error. I'm just saying, hey, I don't want to deal with those errors now. This is a shortcut, but you do want to see what errors there are. And if X is not even passed as an input, it just say, hey, it's not successful because X is not even passed. Okay. So I think I opened that. So let me paste that function here. Nope, that's not the right thing. Oh, it actually went to Google something. Okay, sorry about that. So let me go trigger. Control C, Control V. So sorry, this is the function, and folks can open it if you want. So basically, currently it says, hey, input X was not passed because we don't even pass an input. We can do /? And let's say X is equal to. So like if I don't pass any number, then it will still say, hey, input was not passed correctly, because that's the default, unless we pass something like some number, and we know what the prediction should be. It's just 2.5 times 30, which is 75, plus 3. Okay, so that's the intercept is 3 here in this model. So that's the prediction. Okay, so now this is actually quite scalable. Okay, so you can have this this always running, and you didn't have to worry about, oh, what's the server, what is its maintenance, does it need to have SSH access, do I need to install Python, do I need to maintain Python, and so many other things we don't have to worry about. Okay. So at this point, let me ask if there are any questions regarding Cloud Functions. I know. So what I wanted to show in real time was basically how you go from a Flask app to a Cloud Function thing. And the only difference is you need to specify what are the dependencies on in your um, model serving function in your model serving script. And in the main file, okay, Flask app has a slightly different structure, but at the end of the day, you just need to sorry, this part is just reading a pre-existing model from disk, and these are just imports. So up to this point is just reading the model. Okay. Flask app has the same idea. So if X is in arguments, then try to return with the model file. If not, just do something else. Okay. So this is the commonality with Flask. And in fact, this request object is actually a Flask request object in the Flask framework. And these other things were just imports that were needed. Okay. So if there are no questions, then let's move to AWS Lambda. And I actually had a resource that I wanted to share with folks. By the way, this whole website is pretty good for various different cloud services available on AWS. So for example, if I go to just this website, you can see they have, hey, what are the regions on AWS? What is its history, and what is EFS, and Lambda is what we'll look at. But you can see there's many different things that AWS does. Okay, so highly encourage you to have a look at it. It's a nice illustrative way to understand the AWS vendors ecosystem, right? SageMaker is actually an MLOps related thing, so you can look at SageMaker if you have time. We'll be looking at ECS. Okay, so Amazon EC2 spot instances is what we did in lecture 1 and 2, I guess lecture 2 or the session 2. And ECS is what we'll try to do maybe later this session or early part of next session. Okay, so for now, let's go back to what Lambda is. And is Lambda? So this page is not optimized for MLOps specifically, but Lambda is a service, managed service, very similar to Cloud Functions, and the idea is basically shown here, right? So you basically have this Lambda, is basically a function where you focus on code and not on the server details, basically. So I guess let's start from the top right. As you can see, this person is, we put a no on the server, so we don't care about the server itself. We just focus on the function. There's a single script, just like Cloud Function. Okay, and here they're showing, how there'll be some inputs to Lambda function. Like for example, just like we saw in the Cloud Function, we needed the model file from somewhere, from Google, for example, Google Cloud Storage. Similarly, you can have something from S3 or something from some other database that is probably needed as an input to the Lambda function. Not always necessary if everything is self-contained, but otherwise it'll read something from there, and it basically serves response. It can respond to queries by any external service, person, whatever it is. Okay, and so you just focus on code and just configuring. Okay, there's some configuration that you need to do, like, hey, how much memory would my Lambda function need? Is it 256? Sorry, memory as in how much space? Does the function need, like, it's 256 MB or 1 GB or something like that, and and some permission stuff. Okay, so basically you just need to define your code, which is your function, just like Cloud Functions in the interface where we define the predict function and the configuration. Okay, and that's it. And you can actually define this Lambda using any of these many different languages. I know some of you know C#. Today, in this course, we've been focusing on Python, but you can also use many of these other things: Ruby, Go, Java, Node.js, JavaScript, basically any of these things. Okay, so I thought I opened AWS at some point. Yeah. So what we'll do is, so this, I hope one of you at least checked that this actually works. If you have, then maybe type it on the chat or you can tell me. But let's come back to AWS. So this is the console. Okay. So I just logged in. And previously, what did we do? We went to EC2, right? And they have changed the interface from the screenshot from our notes from last time. But basically, if you click on services, you will see all the services that were screenshotted there. Okay, so this is what I was saying, and you can see there's so many different things, right? So what we currently care about, so previously we cared about EC2, and today we'll be caring about Lambda, which is like the third thing in this list. Okay, and we may also need, on the storage side, we'll also look at S3 as needed. So let's click on Lambda. Thanks, George, for checking. So let's click on Lambda, and actually we'll just do a hello world for now, and then do the same model deployment. So let's just create a function. Yeah, let's just call it some function. Let's see if we can do the weather version. So weather app, and we'll use Python 3.8. Yeah, and that's pretty much it. So let's see if in advanced part do we need to do anything? Nothing. So and then create function. Okay, and very similar to Cloud Functions, you'll also see an editor. Okay, and so you'll see a interface like this. Hey, successfully created this function. You can change its code and configuration. So those are the two parts that we can change. Very similar to the requirements file and the main.py file in Google Cloud Functions. Okay, so if you scroll down, you can see that this is the part where you can change the code. So you can see there's a Lambda function file here. So let me double click it, and you can see, hey, this is the function. Okay, so this is the Lambda handler, very similar to like the target function that will be invoked when you hit the URL. So here you can see this is saying, it's just saying some default thing, okay, which is hello from Lambda. Okay, so what we can do now is basically, let's not change the code for now. We're going to change it pretty soon. So let's click test. And you can see it says create new test event and some event template. Just is, it's just describing what, like some sort of a test description. Okay, so let's just call it test one. And it says, hey, do you want to pass any information? And this is information passed as keys and values. Okay, so let's just keep it the same for this, because it actually doesn't need any inputs for the current function. So let's just do create. Okay, and if you go to the top, so now you can see that there's a test here in the drop down menu, and then if you click test, it'll show you the execution log of what, they basically it ran the test. The test is very simple. It's basically whatever payload we gave, key values, key one value one, key two value two, is just going to use that information to send a JSON payload to the endpoint, and I will talk about the endpoint in a moment, to this weather app. And the weather app is just doing hello world, so it doesn't really care about the input. And you can see what it did. It just returned, it didn't care about the input. It just returned, hey, status code is 200, and the body is hello from Lambda. Okay, so that's basically what the Lambda function did. Okay, so currently it's all within the Lambda ecosystem or the AWS ecosystem. So there's actually not an external URL directly that we can connect that has been connected yet. Okay, so what we'll do next is to connect an external, a way to access this function using an external URL. Okay, so for that, um, we need to do a couple of things. We'll change the code by changing the response function a little bit, and then also add something called a trigger. And you can see it on the left side of your screen, right? There's an add trigger. So we'll click add trigger, and it says select trigger. We'll pick API gateway. Okay, so that's just, think of it as a black box. It's a way to make get us an external URL very similar to Cloud Function, so that hits this function that we have, Lambda handler or whatever is the default function name there. Okay, so API gateway, and then so there's some APIs. So we just have to click create an API, and we're going to create an HTTP API. And there's some minor differences between one or the other, but for now, for demonstration purposes, we'll pick the HTTP API. And security, we'll again pick open. So this is actually not a good idea. As I said, generally you wanna not allow random, I guess, clients to access your prediction model, right? So it has to be guarded. But for a minimum example, we are doing it this way. Okay, and I don't think we need to do anything about the additional settings. So let's just close it and add the API gateway. So you can see it just shows in a block diagram way, hey, there's an API gateway added. It connects to the weather app. Okay, so we'll also need to change one more thing, which is, let's go down to the function. Sorry, let's click on weather app center part. And scroll down, you'll see the function. So let's double click on this. We'll slightly change the return to also have headers. Okay, so generally when the server responds to a query, it also needs to it also responds with a header field. Okay, so we'll add that field. It's a dictionary with content type being, and so this is just some default information that needs to be there. So we are not very concerned with this. Content type and JSON. Okay, application/JSON. Okay, so and then I click deploy, and now we have this. Now what we need to do is click the API gateway. When we click that, you'll see that, hey, the function editing, the code editing portion was removed, as in it was hidden. And you can click on details here, and it'll show you the endpoint. Okay, so this is the link. So let's click on that link. Okay, and if you click on the link, basically it says hello from Lambda. Okay, and this, since it's openly available to I think everybody, I'll just paste it on the chat. So this is what it is. Okay, so now that we have the basic infrastructure for Lambda set up, what we need to now work with is to somehow go into this code base and say, hey, how do I make this now like serve models, for example, model predictions. Okay, I chose the wrong name, weather app, but let's just use weather app because that's what was demonstrated in the notes in addition to the model. But let's directly skip to the model part. Okay, so what we need is a way to return the model prediction. So let's go back to our Flask example. Yeah. So we'll do something similar to what we did before. Um, so in the notes, actually, I have that section talking about, again, programmatic access to the storage service by AWS. It's an equivalent thing to the Google Cloud Storage. And I have a, so let's see if I can show that in real time. Yeah, so this is what we have done so far. So let me scroll down to where we are. So we configured a test event, we saw this, we set up an API gateway, and we saw that it works. Hopefully, again, somebody can check. But once we did that, this part of this section of this subsection of the section is talking about how to do, again, in a programmatic way, as in some sort of a command line way of accessing the storage. Okay, because we need storage so that we can save our model and things like that over there. So, but the rest of the description in this note, in this section, is talking about a programmatic way to do so. So I am trying to decide in real time if that is a good use of time. Yeah, I'm thinking. Let me skip that and do it in again, upload our model in a non-programmatic way, and then um, um, and then go from there. Okay, so um, actually, even a slightly easier way is to so what I was thinking was we'll skip the programmatic way of accessing storage. If we skip that, there's a GUI based way to access storage and create same thing, bucket and file and so on. But there's an even shorter way, which is, if you can see here in this function code, there's an action at the top, right on the function code line here. There's an action at the top right. So if you do a drop down, it says upload a file from S3 or upload a zip file. Okay, so what are these files? These are supposed to be like a folder where something like this exists. Okay, so if you had a local folder, okay, and a zip file, a zip file folder which had just this lambda function .py file, and you upload it from the local machine, then uh, that's one way to uh, change this. Okay, so for example, right now it says lambda function there. So if I upload a zip file which has the same file, then it'll overwrite it here. So that's one way. That's even shorter way than to upload a file from Amazon S3. So if you click on Amazon S3, it'll say, hey, give me the S3 link, and I'll upload the file. So this uploading a file, so uploading a file from AWS S3 is equivalent to getting that model from AWS S3. Okay, so or from some storage. So what I'm trying to say is that you can ideally, in an ideal world, you would be working on your model, train the model, dump it to S3, and then when you're setting up your Lambda function, you will upload a file, or upload that model file, for example, from through this interface. Like you can just click on that and say, hey, where's my model file, and upload it from there. Okay, so we're gonna skip that part, and and so I'll just demonstrate how to upload. I mean, and this I think is probably everybody knows this already, but I have this lambda function.py file, which has exactly the same content as before. So I just created a zip of that. So let's say we upload this. And press OK. So now you can see that this is not the part. So now you can see that it says, hey, you did upload. Okay, so for example, like, I can delete this and save it. And now if I upload, let's say, same thing again. Okay, now you should be able to see that Lambda function, right? Let's close this. Okay, it's taking some time. Interesting. Okay, looks like the upload did not work. So let's actually delete this. And sorry about that. So I think I am facing some issue here. Interesting. Okay, I think I am not able to upload the file directly. I thought I will shortcut it, but okay, that did not work. So let's see. So I'll try one more and once more, and if it's not working, then let me jump over to the next part instead of consuming real-time bandwidth. Okay, now unfortunately, because I made it that way, the function is 2 levels down, so it will not work. So anyway, so this function should be on the should be, the zip file should be such that it's at the top level. Okay, so now it's not even moving. Okay, anyway, so I think what I'll do is not show the so not show the deployment of model on AWS Lambda, but just know that it's a very similar process. Instead of S3, I'm just saying that you can just upload a zip file with your model pickle file, so that it's directly available here. Okay, so maybe I'll do that offline in a separate recording and share it with you guys. Let me write that down actually. So I'll have that recording for just a simple regression function. Okay. So so what else is there to talk about for AWS? Yeah, actually, that's pretty much brings us to the end of this serverless technology ideas. So let me. Yeah, so what I was trying to do was part 6 of the sixth section of this module, and I skipped over the command line way of accessing S3 because I think it looks like it's better to do it using GUI for now. At later point of time, if we need, we'll again check that part out, and then the deployment of the simple regression model I skipped it over for now because I want to get to Docker and containers today. So the last thing for this section is how serverless technologies work behind the scene. There's there's a lot of things going behind the scene, but I would say if you have a time or bandwidth, you can look at that. Um, an interesting challenging thing would be to, if you have a custom domain, okay, for example, I have a custom domain for my website. So if you have a custom domain, figure out how to link that to your cloud function. Okay, so instead of that long URL, like these long URLs here, or the previous one, um, you can use try to use your own short URL. And finally, there is as I said, there is a difference between programmatic access and manual access. Manual access is basically where or the GUI based access. So it'll be good if you can also look at the notes, which have actually a description of programmatic access to GCP as well as AWS. There's also this notion of identities and roles, and you'll see that when we do the command line version, programmatic version, we need to create some sort of very similar to the PEM file that we were working with. Similarly, we need to have like a secret key and access key, basically. Not just exactly the same names, but basically we need a authentication keys using which we can access, from any machine. For example, if you want to access GCP stuff like Cloud Functions or the Google Cloud Storage from our machine, which is on AWS EC2, right? It's in AWS EC2. So from there, from AWS EC2 machine to talk to Google Cloud Storage, on the machine, there needs to be some like secret tokens using which we can access. Okay, the tokens are just think of them as long alphanumeric strings, which should be kept secret. Okay, and that's about it for section 2, or sorry, chapter 2. So any questions here before I switch topics completely back from serverless world to a slightly different world, which is about containers and so on? Okay, if there are no questions, then let me go back to, again, just to reorient ourselves, let me go back to syllabus. So where are we? So we basically covered how to serve ML models using web servers. Okay, and we just scratched the surface there. Certainly we picked one particular tool, Flask Web Framework, and we know how to do model training offline, right? Whether it's R or Python. And here some of you are new to Python, but model training in Python is very similar to model training in R or any other language. So we just coupled it with a web framework. That's what we saw a few lectures ago. And then recently, last lecture and this lecture, we've seen how to use the serverless infrastructure, in particular Google Cloud Functions, as well as as well as Lambda Functions. Okay, these cloud functions, the serverless infrastructure or serverless techniques have some pros and cons, and the pro is that you just care about code and just setting up the requirements document or some sort of like a config information and your code and your script, and you don't care about which machine it's running on, and many other things that are needed to get a server going, right? And we did that in the first session. So but there are also cons. Cons are basically that these functions, just think of them as sleeping functions, in the sense that every time a HTTP request comes, for example, the function wakes up and does all this initialization. For example, you saw in Cloud Functions, I was reading the model every time an external request came in. Okay, so I was reading the model from Google Cloud Storage. So that's inefficient. So there are some ways to get around it. That's one con. And the second con is, the first con is actually related to latency, right? So if a request comes and the function does a lot of pre-processing before being able to make a prediction, then that pre-processing steps is going to consume time. So your response will be slow. Okay. And the second con is resources are going to be limited. Okay, and we didn't get to see that too much, but as you saw, for example, the memory for our Cloud Function was up to 4 gigs, as well as I think on the Lambda function side, the storage itself is probably 256 megabytes storage, not memory. So there is, severe limitations on the environments within which this infrastructure is running. Okay, so for you, in the sense that you cannot deploy a very heavyweight, function which needs like gigabytes of memory or gigabytes of space to do some processing. Okay, that's not the use case for this. Okay, so with that, let's jump over to the next, I guess, um, uh, new technology, which is very useful for not just ML model deployment, but also in general for reproducibility aspects, as well as keeping your, making the, um, uh, you know, software engineering process pretty smooth by being able to make your environments portable across machines, across dev environments to production environments. Okay, so so in particular, our learning goals are as follows. In particular, I'm going to only focus on the first two for today because we only have 20 minutes. So we'll talk about the pros and cons of container technologies, and also differentiate them from virtual machines. Okay, and also talk about the larger context of where do they come into the picture and how do they help us deploy ML models. Okay, since that's the running theme of this course. So, and then next time, I mean, if we have time today, we'll look at how to create, pick up a particular instantiation of this container technology, which is called Docker. But most of this we'll try to touch upon next time. Okay. So, oh, that did not work. Actually, I should just be using this maybe. Actually, yeah, there's several ways to access the same thing. So we already cloned these notebooks, so we can also run it from our remote machine. Yeah. So what we're going to look at, is the goal for this chapter is mostly to use containers on AWS eventually. But we're going to look at two technologies or two specific instantiations. One is called Docker. The other one is called AWS ECS. Okay, and ECS, again, we can go back to this this website and we can search for ECS to look at it. But we'll do that next time. So, so what's the problem? Okay, so the problem that folks face in productionizing ML models or anything actually is that this environment compatibility is a headache. Okay, so when I say environment, we're talking about, hey, what is your Python version? What is your scikit-learn version? What is your pickle version? There's so many versions for all the underlying packages and software. Also, the underlying, for example, like if it's on Ubuntu 2004, or is it Ubuntu 19.10, for example. Okay, so that versioning issues and the and varying environments across different machines. Okay, so for example, if you and a few of your team members are working on the same ML model, the training environments could be different because your machine may be different from their machine, and it could be as simple as like some minor difference between packages, which may cause some hard to trace issues, for example, right? So these version issues is a big thing, in addition to usual issues like scaling of your app. So for example, if you have a model serving service, and now instead of 10 customers, you have 100 customers or 100 clients querying for predictions, then how do you now stop your model, rent a bigger machine and bigger, let's say, EC2 machine, and deploy a model again, or is there some other ways to get around it? Okay, so so the usual issues are the problems like scaling, security, maintenance of the software and hardware. So in serverless example, actually we did not see this, but there was this need for a different version of pickle in the recommendation system example that's there in the notes. But so we did not see this time, which is good. So there is this issue of versions. Okay, and if you do if you do the hosted way of doing things, which is where you do DevOps yourself, or you as an you have a separate dedicated team which instantiates the servers, maintains them, then there's a lot of hard work to ensure that not just that these machines are running well, but also that these machines are running on the same software environments. Okay. On serverless, we just did it in a very config, in a very lightweight way, because everything else was managed by the vendors, in this case AWS and Google. So we just had to pick the requirements.txt file and just say which Flask version. We did not explicitly say which Flask version in our example, but you can say, hey, Flask is equal to 1.0.3. We just need that version, for example. So that would at least ensure that whatever you try to work with in your local machine, let's say on Flask version 1.0.3, you have the same version running when you deploy it. Okay. Another solution. So serverless, as I said, has its own pros and cons. A more, I guess, a popular solution, which a lot of folks are using these days, is the notion of containers. Okay, and containers are basically a way to encapsulate your just the environment about your program. Okay, so if we program it on our EC2 machine, for example, the EC2 machine has its own configuration, right? Maybe it has some amount of RAM, certain software, certain Ubuntu thing running, and all that. But containers let you encapsulate your arbitrary program, like our model training script or model prediction script, um, encapsulate it such a way that it can run on many different locations. So, for example, we run it on our EC2 machine, the remote machine. We can also take the same encapsulated thing and run it on our local machine, or run it on our friend's EC2 machine, or on Google's cloud compute instances, or anywhere else. Okay, or DigitalOcean. We can just literally, it's some sort of a package thing that we can keep moving anywhere. Uh, and the way it works is basically um, that as long as there is one piece of software in all these other locations, then there's going to be virtually exactly the same experience, okay, of running your model serving code anywhere. Okay, and that extra piece of software is for example called Docker. Okay, it doesn't have to be Docker, it can be, there are many other choices, but Docker is one example. So for folks who know Java, I don't know if anybody knows Java here, there's this notion of a JVM, Java Virtual Machine, right? So you write your Java program, and if there's a JVM on an ARM machine, or a x86, or a 64-bit machine, or a 32-bit machine, as long as JVM is running there, your Java code can run on any machine, right? So it's a similar, it's similar in that pattern. Okay. Um, so there are several use cases. Web apps, which is what we saw with Flask web framework. What we did is a web app which serves predictions. Model deployments, which is but web apps can also be many other things, right? Like dashboarding or business intelligence reporting that folks do. But our objective is generally theme is model deployments. But also there are other use cases. For example, you can snapshot your project. So you worked on a 6-month long project, let's say in one of the courses. Then so that you can snapshot it all into a container, basically a container related, I guess, some object, such that 2 years later you can, as long as you have packaged it, you can run the same thing and get into the same environment later. Okay, and not just you, but you can share it with other folks, and they can have the same environment, so that there is no issues of, hey, this code is not running now because it's Python 3, whereas when you wrote the code it was Python 2.7, for example, right? You will not have those issues. So just to, I guess, summarize, containers are tools for producing. Let me actually, tools for producing reproducible environments. Reproducible environments, and it can isolate many tasks. So the key idea of a container is that it is a process. Okay, so what is a process? I think we'll not get into the details of what's a process, but let's actually do this command here. PS. Okay, so if I do PS, you can see that okay. Okay, so this Ubuntu user on this Linux machine, this Ubuntu machine on the, I mean, so we are the Ubuntu user actually. This is my machine running on AWS, right? So similarly, all of you may have similar machines. So you can see there's so many processes running. Okay, so this first column is called process ID, and it's like some time information, and what is that command or some sort of a program basically. And so every program or command generally has a process ID. Okay, and so there are several instantiations of Pythons. They have process IDs, and it's not clear what they're doing. But so this is what is meant by process. And containers are just a process on the host machine. Okay, and the host machine typically is Linux, so it's just a process on Linux. Okay, so you can, and I think some of you who have seen Windows, if you do Windows Task Manager, you will see a bunch of processes, right? So container is just one of those processes. Okay, um, uh, so what they do is that it's a process, but it's a process within which they can run your our ML deployment code or ML training code, such that when the code is running, it'll only see a limited view of the world. Okay, so it'll only see uh, you know information that is not system wide. For example, if you're running this container on sorry, if you're running this container on the remote machine on AWS or a remote machine on GCP, the code that is running, like the model deployment code, is only going to be limited to what the container allows it to see. Okay, so it doesn't matter whether the machine is on AWS or EC2, or if it has a lot of RAM or a lot of storage or whatever. It's only, or if it has different software versions, more importantly, it's the program that needs to run. In our case, the model serving code is only limited to what the container lets you see, and in that way, and it's basically some sort of an isolation. Okay, and in that way, you can have this portability. Okay, so in that sense, it's similar to a virtual machine. So if some of you have installed VirtualBox or VMware Fusion or any of these virtualization technologies and started, let's say, on Windows, you can have a Mac OS running, or you can have a previous version of Windows running, or Linux running, right? So it's that's a virtual machine. So in a virtual machine, like once you log into the let's say if you're running Linux on Windows, once you log into Linux, if you run run a command there, the command can only see that it's running in Linux. It doesn't know the bigger world, which is that the Linux OS itself is running as a virtual machine inside Windows, right? So similarly, um, a container is also very similar in that sense, but it's at the same time it's much lighter on resources because of certain reasons. Okay, it's not the full virtualization that you would achieve on a virtual machine. Okay. And that's because, as I said, we are this container is going to be just a process, like just like a Python process. Here there'll be a container specific process, which means that it's actually running on the original machine, okay, as a process. So, and that's why it's more I guess a lightweight compared to a virtual machine. Okay, so virtual machine needs to have full-blown Linux environment within which a program will run. Here it's not a full-blown OS within which the program is running. It's the program, our program, target program, is only running within a single process. Sorry, let me come back here. And yeah, so that's pretty much the difference between VMs and containers. Yeah, and I guess the final thing is one implementation of this container idea of having a process, our target program running within the process, and not being able to see what, whether it's running on Linux, Ubuntu 20 or Ubuntu 19 or whatever. This implementation, an implementation of this is by this vendor Docker, or the software Docker. There are other implementations as well, as I was saying, called Podman and so on. But this has become, I guess, popular. So we'll look at one of these implementations. Okay, and later on, so Docker is something that we can play around ourselves. Like for example, we can pick a machine, like just like the EC2 machine that we chose, and on that EC2 machine we can install this piece of software, Docker, and also we can install the same piece of software on, let's say, our local machine or some other machine. And if we work with a container using this Docker software on any of the machines, we can have the same container, have the same behavior, on any of the machines. Okay, so that portability is what it gives us. But this required us to, let's say, start an EC2 machine. Okay, what the Elastic Container Service, which we'll see towards the in the next class, does. It's a service. It's a managed service by AWS. So Docker by itself you will consider it as a hosted service, in the sense that you install the software, just like we installed Anaconda, right? It's going to be something like that. So we'll just install Docker ourselves. So that will be a hosted solution. AWS provides the same idea using a service called Elastic Container Service. So container service, as the name implies, it's basically about, hey, you don't have to worry about installing Docker on your remote machine. We will take care of that. You just have to somehow give us some sort of a container object to us. Okay. We'll talk about the appropriate terminology here. I'm just saying container object. The actual name is called an image, but so we'll talk about this next time. But AWS is one example of a vendor which can provide a managed service like this. Okay? And the service in particular is called Elastic Container Service for AWS. There are other similar equivalent services by many other vendors, including Google, Microsoft, and many others. Okay. Yeah. And so in the next class, what we'll do is look at play with Docker locally. When I say local, it's all about, as I said, in any work session, we just SSH into that, not SSH, but tunnel into a remote machine. In our case, this 8889 location, right, on the AC2 machine, and we'll try out Docker there, and then we'll try out Docker on. So I guess this two are the same, and then we'll try out Docker or container ideas using the managed service in particular by AWS, and that requires Elastic Container Service. It also requires a sibling service. It's called Elastic Container Registry, and we'll talk about what is registry, what is Elastic, and all that when we get there. Okay. The main important thing is there is a container technology which is like an idea. The implementation of that idea is Docker, and we'll start with Docker first in some sort of a managed solution mode first, and then move on to, in some sort of a I would say, hosted solution mode, and then we'll let the vendors take care of it using the managed services like ECS. Okay, so the end goal, basically, after all this effort, whatever effort we'll put in next time, is going to be that we'll have a lot more control. Okay, so as I said, there are some cons in using serverless. Serverless is really useful for very lightweight functions, lightweight things where you don't want to care about the server, but at the same time, you're happy with like everything being managed. Okay, so and in that sense, Lambda functions or cloud functions are also a little bit more expensive. So here you will get almost the same functionality as serverless, but a little bit more work and a little bit less cost, but allows for more flexibility. Okay, so you can, for example, if you have a container object on AWS and tomorrow you'll say, hey, I don't want to use AWS, I want to use Google Cloud, you can very easily, like, you don't, it's just like 5 lines of commands to run to move from one cloud vendor to the other, right? So that portability is like super huge. Whereas serverless, you still have to do some extra, peripheral work to move from, let's say, GCP to AWS, or from one machine to another. Okay, so I hope that gave you at least a high-level context of what containers are and roughly how they're different from virtual machines. Next time when we pick up Docker, as we go through some minimal examples, we'll get a much more better idea about container technology itself, and then there's some terminology associated with this technology, and so we'll talk about that next time. So any questions about this part? No questions? yeah, if there are no questions, then let's break in terms of the official meeting. So thank you for folks for staying on, and we'll resume next class, and we'll talk about we'll install Docker and try out Docker. Okay, and it's a really very interesting technology, and I hope it'll be interesting next time as well. So thanks, and now I'm going to stop recording, and folks who have questions can stay back and let's talk.